and we can go from there. So, welcome everybody, and thank you very much for joining me today and for your interest in the brand new Tech Art program here at Vertex. I'm actually incredibly excited to talk about this with you today because the last few months at Vertex have been the most exciting since I've been here. If you don't know me, my name is Filipe Strazzeri. I'm a lead technical artist at a company called D3T. We specialize in code development, and I'm also the head of tech art and game development here at Vertex. I've got about 15 years industry experience, and before I was in games, I worked in visual effects. So some of the recent things that I worked on was things like Alien Romulus. I've worked on The Witcher for Netflix. I've also helped on House of the Dragon and a bunch of other Netflix things. Biggest thing I've contributed to for the longest time was the three body problem, where I supervised the pre-visualization all in Unreal. So did lots and lots of things with virtual production and basically using Unreal to do things it shouldn't do. I got into Unreal a long time ago, and it wasn't really ready for lots of things that it does today. So it's really evolved into quite a big beast. So the reason I'm super excited is that, in recent weeks, we've launched two things. First is the Tech Art program that we are launching very, very soon. And the second thing is we've done a blueprint bootcamp because that's how I got into tech art. My background is character art. I used to be a sculptor, and I guess I still am. I just don't do that anymore. And yeah, just lots of character art, anatomy, things like that. And, your traditional hard surface, organic modeling, etc. That was my bread and butter. And I worked in VFX in that. I worked in games with that. But I've always wanted to make games. I always wanted to be sort of technical. But I was a very visual person. So whenever I would, go look at a course at Udemy or something like that, we're talking over 10 years ago now, it would be these programmers teaching you things and sort of expecting you to know what they know. And it wasn't really very good for me as an artist. So one of the things that happened and the way that I got into tech art is that I learned blueprints in Unreal. And that like really, really blew my mind. And I like to tell this story because it's really important, I think, for you to sort of try and understand like where your path is going to be when it comes to becoming a tech artist. We're going to talk a lot about what a tech artist is. I'm a lead, I hire tech artists, so I should know what a tech artist is because I need them for my team. And so it's really, really important, I think, for me to set the stage and for you to understand how things happen, right? I joined a company here in the UK. This was many, many years ago now, and they were developing a VR game. All I had was Unity experience. Like I said, I tried some tutorials, I built a few things, but I wasn't really comfortable with programming or anything like that. I'd never used Unreal before, and luckily for me, the Fortnite white paper had just come out, and that white paper was they made the first cinematic for Fortnite in Unreal. They had finally introduced sequencer, doing all these things. It was really, really cool. And I was working at a company called Framestore at the time, and they had the presentation there. I joined, and after the presentation finished, I walked up to the presenter, a guy called Dave Hibbets, and I walked up to him and said, "Hey, I'm a Unity person. All these folks are using Unreal. What do I do?" And he recommended a course for me, and it was like this course that said like build your first two games in Unreal, and it's quite outdated now. It's still out there, by one of their evangelists, Chris Murphy. And in that course, it just kind of completely blew my mind and changed everything for me. It literally changed my life because it was the first time where I could visually understand what code was doing, like code logic and flow and all these things. I built my first little prototypes, like mostly gameplay things, like a first person sort of platformer, a top down thing, a third person thing. But it let me really get to grips with the engine and start to do things that, normally it wasn't meant to do. So I immediately applied that to the VR game that I was working on at the company, and I had loads of people help me and mentor me while I was there, and I built the first tutorial level for the game. So I started out in gameplay, really, and that was like loads and loads of fun. But with that understanding of programming and blueprints and things like that, I sort of wanted to know more because when I spoke to these programmers, they would say things that I wouldn't really understand, and I couldn't keep up with them. Like there was something that I was missing. And so as I started my career as a technical artist, I kind of came from a really weird angle, right? I started from blueprints and gameplay and building prototypes and sort of, I built this thing that would help visualize what a queuing system would look like in a roller coaster theme park, like in China, for example. I had to like play video in all these screens, so I had to figure out how do you play video in Unreal and actually project it onto a plane. Things like that. So I leveraged my modeling skills, my UVs, my textures, all that stuff, and then started to do techie things in the engine. But one of the things that I got very annoyed by very quickly is that lots of my tasks were very, very repetitive. And at my job, I also had to do a lot of rigging. So it's not uncommon for some companies that want like generalist asset people to also do a little bit of the rigging. And I just realized that I had to do so much in Maya that was repetitive. I had to unlock, lock attributes. I had to get a bunch of things, place them in a specific way, or, just very repetitive tasks. And that led me into Python. And in Python, I started to learn my first programming language. And that was really, really powerful because for me, coming from blueprints, not really understanding what things were and seeing something, like a Boolean or an integer or a floating point number, I didn't really know what those things were. And then when you get into sort of like a classic programming language, you start to kind of see things. And then you kind of realize that blueprints is really quite messy. And when you start writing code, it really starts clicking. It was really formative for me to go into coding from blueprints first because it took all of the sort of complicatedness, abstractness away. And that was really, really powerful. And I remember I was starting to build pipelines and tools. I started to automate my rigging. I started to build these tiny little scripts. And eventually I started to build full-blown tools, like rigging tools, automation tools, renaming tools, texturing tools, all kinds of things, animation things, to kind of bake animation, work with Houdini to say auto-generate node trees, to export simulations, alembics, all kinds of things, right? It all started to kind of come together. And with that and my generalist knowledge in Unreal, I could really bridge the two together. So, you can use Python in Unreal. I started to do those sorts of things. And that was really, really powerful. So as I progressed in my career as a technical artist, I wanted to continue to know more. I went from blueprints, which is, fairly high level visual, went into Python, but just didn't get how things worked. And as a tech artist, you have to be really driven. You have to want to learn things. So I remember speaking to one of my mentors while I was working, and we were talking about folder permissions on Linux because we worked in visual effects, and a lot of visual effects works around the Linux operating system, especially for rendering the plates and all kinds of things. So I remember him saying, "Oh yeah, we have a write permission issue, so we just have to flip the bits." And I was like, "The what now? What do you mean flip the bits?" "Oh yeah, because read, write, execute. Those are you're just flipping bit flags." And I was like, "No, I don't know what you mean." So that led me to think, "Oh my God, this person knows way much more than me. What do I do? I need to learn." So I continuously tried to push, go forward, and then I sort of got myself into a little bit of a computer science background. Started to look a little bit more into graphics, rendering, and then most importantly, started to dive into C++. And that was a real game changer for me because I had a gameplay background with an art section, and then I could do shaders, Python, tools, gameplay, all kinds of things. So I became this sort of really, really big generalist. And now here I am. So I'm working as a lead, and I do a lot of work specifically focused on performance optimization because I have more knowledge about the low level stuff that happens at the computer. But I also build a lot of tools. I automate the art pipeline and I help artists as much as possible, right? My biggest thing is to try and help folks make their lives easier, right? If they're doing something repetitive, my favorite thing is to build them a tool that helps them do it in one click. Those sorts of things. Like I'm sort of like a process optimizer. I am someone who empowers the whole team, and I can save weeks or months of work by writing a Python script, a C++ script, or, do even more. Because I worked in visual effects, I also did a lot of particle systems, a lot of lighting. I worked with directors of photography, directors, all kinds of things. So I have this sort of very strange and, all-encompassing path into tech art, which for me has benefited me greatly because it's allowed me to kind of be a bit of a chameleon with any project that I join. So saying all of those things, I thought, well, how do you build a tech art program, right? Like that's a lot, right? All those things that I said. Well, I think you have to answer a few questions. Like, first one is, what is a tech artist? How do you become one? And then, how did I build this tech art program? So after we answer these questions, I'm going to go through and have a Q&A with everybody. So if I come through here, the first thing I thought to do was like, well, I shouldn't tell you what a tech artist is, right? You're here. You probably want me to tell you what a tech artist is, but why don't I tell you what the jobs are saying? Because if you look at a job, it should tell you what it wants, right? So why don't we look at some jobs together so you can understand what is a tech artist? So here's a technical artist job from the UK, a company called Radical Forge. Here is the stuff that you need to do. Pipeline development and art optimization. So you need to know art and you need to develop pipelines. Okay. Tool and script development to support the art team to streamline workflows. Okay. So tooling. First big things here are tooling. Okay. So they want you to build tools. Second thing, shaders. Okay. So they want you to make materials. That's good. And then they want you to communicate technical requirements and bridge the gap between teams. They want you to document pipelines, procedures, etc. Documentation is super important because if you're going to build tools, you need to teach people how to use them. It's super important to write documentation, and I push all of my tech artists to absolutely have like a little help menu in their tools that links directly to like a Confluence page or something like that. So, there's other things here that are interesting. VFX and particle creation. Okay. Solid understanding of runtime performance costs, what that means. Again, shader development, that sort of stuff. So we're seeing that this tech artist is shaders and pipeline. Okay. What about this tech artist at Epic? You have to have experience of PBR. You're going to create complex materials for characters, weapons, and environments. So shader stuff. You're going to establish workflows and tools. Okay, shaders and tools. We're hitting the bingo card with those two a lot. And you're going to work with engineers and artists to optimize content. So again, bridging that gap, right? Speaking between departments. Cool, interesting. There's a lot of other things here, but pretty much same one as the previous one. Okay, let's look at another job, right? So design, prototype, and implement stylized materials. Okay, very specific. Again, materials, shaders. So this was starting to take shape in my head. Oh, I looked at it. I know what a tech artist is, but tech artists can come in many shapes or forms. They tend to be specialist generalists or just specialists. And there are pros and cons to being both, I would say. So look, optimize materials and performance. Performance is popping up a lot, right? That's interesting. Build and maintain modular scalable material system, troubleshoot debug materials. So this person that they want to hire is very material heavy. You want to work closely with VFX and lighting so that everything works. So this looks like, a material person. HLSL here, shader creation, understanding GPU performance. But hey, it's also saying you should know Maya, Blender, Painter of the bits and pieces. Okay, interesting. Here's a lead position, right? Now, most folks here aren't going to be necessarily lead tech artists like me, but it's really interesting to kind of understand like what a lead is and what a mid is. Like, what are they expecting of someone as they progress through their career? So, mentoring, reviewing, cool, interesting. But you lead technical problem solving, support debugging, you are looking at performance, you oversee shader development, shaders coming up a lot. You need to maintain a high quality of visual bar, all this other stuff. Like, and also, again, develop and maintain pipelines and tools. Sounding pretty interesting. Here's Python. Here's Mel or MaxScript. You need to know Maya, Blender, Houdini, Substance. Houdini, interesting. Good to know, right? So pipeline, Unreal, blueprints. Hey, you need to know blueprints. Interesting. The lead suddenly has a lot more skills requirements than someone else. Okay, what about this one? Solid scripting in Python, fundamental knowledge of rendering pipelines, and good knowledge of Maya. Interesting. Funnily enough, that's my previous job. That's literally my previous role. That was the job description. So there's a lot of these jobs, right? So, here's one from Rockstar. I just want to show you what the jobs are saying so you can understand what a tech artist is. And then I want to sort of explain a little bit more about why I built the program the way that I did and what we're going to do there. And I also hopefully want to do a bit of a demo today, everybody, where we're going to build a tool together so you can get a bit of a gist for my teaching methods, how we're going to do it, because the course is going to have live sessions every week. It's once a week. And obviously, it's 5 terms, 12 weeks each. It's a long time because it needs to be a long time. And we'll get to that, right? So, looking over at these jobs, this one here has a little bit more about animation, right? But look, developed automated solutions to process data without input. Interesting. So this looks like a tool person, and they're asking for coding and building custom tools and UI. Really interesting stuff. It's a senior, but still very, very specific, right? So very specialist. Here's one for Blizzard, right? And you can see there's a lot of jobs, right? Interesting. These are all live, by the way. I haven't picked this from like 3 months ago. These are all, I literally looked these up on LinkedIn to get the most recent amount of stuff so I could talk to you about it. Strong foundation in Blueprints, Python, HLSL, C++. Wow. Okay. That's an extra. And there's a lot here, right? I think this one is from Naughty Dog, Substance Designer, Painter, Houdini. Houdini coming up again. PyTorch, Python, C++. There's a lot of stuff coming in. And again, coding skills in Python, C++. You get the point, right? Cool. So I kind of, there's this question like, everybody says, well, tech artists are like gold dust. We're called unicorns. Why? It's really hard. There's a lot you need to learn and so much complexity to each topic. A tech artist isn't just someone who suddenly comes into a project and knows everything. You tend to come from a specific background. You've kind of got annoyed at something. You wanted to automate it. You want it to be more technical. You know that you can make your life easier. You see someone program, you like, that's wizardry. I want to do that. And so you start to choose your own path and you get built around the projects and the needs of your project, right? As there are requirements and tools and shaders and all these other things, you step up, you go learn it, and you go do it. And that's the kind of tech artist that you become. So we all have our own paths. And what I thought would be interesting is for us to see like a little bit of a world cloud of what these jobs are. So for me, when I looked at a tech artist, looking at all these jobs, and obviously from my experience, not just off of the jobs, this is what a tech artist is. And this is why it's so hard. So you need to understand proceduralism, you need to understand profiling for performance, you've got to give people support, you've got to know blueprints, you've got to know how to build a pipeline or operate within a pipeline and expand upon it. So you come into a code base, you need to be able to make modifications to it. You should learn Python, you should know tools, you should definitely know shaders. So HLSL, GLSL is an extra. C++ can come in handy. You'll sometimes build VFX, and you should probably know Houdini. That's a lot, right? So I thought, okay, the best thing to do today as well is to talk to you about what are some example things that you'd have to do on a day-to-day as a tech artist. So what are things that I personally have had to do as a tech artist in my day job, in my career of many years now as a tech artist? So on the shader side, I've had to create master materials, material instances, shaders that blend between multiple masks, things that deal with trim sheets, decals, those sorts of things, using custom primitive data instead of, trying to use texture samples to save on performance, all those sorts of things to add material variance to things in a cheap way. I've had to use things like distance fields to build like foam, grime, and special effects that are, interesting and require extra math and, more complex things. And these are some of the examples of things, some of these are just thumbnails that I got from YouTube. This is from Visual Tech Art. This is a tool that I've had to build where I've used custom primitive data to kind of generate physics on an object. So this one's a lot of fun to do. So it basically swaps the texture based off of custom primitive data. So it's very, very cheap, uses an atlas as well. So lots of interesting shader techniques there. Even if the assets are very simple, you can see the effect, right? The tech artist should know how to build an asset. So you should know how to model, but sometimes all you need to do is have a simple thing. It's UV'd in the right way, and you give that as a template to an artist, and then they'll go ahead and do something about it. So building a system that can, as you push a mesh into another mesh, suddenly they kind of blend together. That's a really useful thing to do. And, these are some of the best examples of why folks need tech artists on a project. Building system like a water ripple thing, or, foam on an ocean using Gerstner waves and more complex things, right? So that's what day-to-day tasks would be. You'd probably be doing something like volumetric clouds, building materials, helping the team out as much as possible, doing these things that they don't know how to do because you understand how to make art with maths, right? So when you think about tasks for tooling, because there was a lot of tooling requests on those job descriptions, right? I've built tools that resize multiple textures at once. So I'll show this as an example in the video shortly. We were working for the NFL and we had to build, so this wasn't even in games, this was in visual effects. And we had to basically get all of the team logos into these scorecards that we were doing digitally with virtual production because they had like the digital sets with the green screen and etc. And all of the team logos that we got were like a horrible size. They weren't power of two. So as soon as I chucked them into Unreal, they would just stretch the logo immediately. And they were all kind of uneven sizes. It was a nightmare. It was terrible. And there was like, I think like 168 of them or something like that. It was loads. It was terrible. So I built a tool to resize that. I automated a load of rigging things. I'm not a rigger, but I became a rigger just by automating the process, and I learned a lot from it. And I've done things like bulk renaming, exporting of assets, streamlining a pipeline process. I've built pipelines multiple times now that when you hit a button in Maya or Blender or Substance Painter, it will literally take what you have on the screen, export the FBX out, send a connection message to Unreal, bring the assets in through an import pipeline, actually name the asset properly, set up all of its shaders, pull in all the textures, and it does all of it in one click. I'll show you this in a demo in a bit. So this is the tool that I built that was meant to convert these images. And you can see that there are a lot of images here. Like these are 20. And within a second, they all get converted into power of two. And then I built this thing to say resize the images by half the size, do all kinds of other things. I built a lot of rigging things. I've had to automate the process here to make this car move as you move it. And, as the wheels scale up, it changes the rate that the wheels rotate, those sorts of things. So I have a very generalist approach to things. Um, and I've had to do lots of it, right? I've been around the block doing so many tasks. Um, and so I'd have to I tried to put in the other slide here for the asset pipeline, but I'll just drag my portfolio in and I'll show you that in it after the presentation's done, so you can kind of see what I meant of like the one button click from Maya to Unreal. Sort of that was a really cool thing that I did. Um, when it comes to blueprints, I've had to do lots of stuff. Like I've modified weather presets and patterns. Working in visual effects, you wanted to know the time of day for the shoot. You want to know where the sun is because you need to know how much shoot time you have. You need to know when the sun's going to set and when the clouds are going to start shifting, because as soon as the clouds start getting onto the set, you start ruining your shots, for example. So I've had to do lots of stuff like that. I've had to build loads of particle systems. Like I've done things like kick up for cars, skid marks, etc. And I've also built many, many tools to say stack things, scatter things, spline meshes, all kinds of things you can imagine using PCG, so procedural content generation. I've done a lot, right? And as an example of all these things culminating in one with my gameplay background, this is sort of one of the things that we do in the game dev program where, we have particle systems, we have, the enemies getting dissolved, all this sorts of stuff, like everything working together with gameplay, right? You need to be able to integrate your work with gameplay. So with all of this being said, it being a lot, I figured, what is a junior technical artist? What's going to give you the biggest chance? And there's kind of no way around it. You need to know all of these things. You need to know shaders, you need to know Python, you need to know blueprints, you need to know a little bit about VFX because they're linked to shaders and multiple other things. You need to know how to build tools. And from everything I can see in my personal experience, Houdini is a really powerful tool that is always a nice card up your sleeve to have. Now, if you wanted to compare this to the things that I can do, it looks a little bit like that. Now, I'm slightly off the curve when it comes to my time experience and my interests and where I've specialized and the things that I like to do. But what I wanted to show you with this diagram is to say, if you want someone to teach you the things on the left, they should really know all of them. And I do, because I use them on a day to day. Nowadays, I use less Python than I do C++ because I'm in Unreal a lot, and working with Python in Unreal, it's a little bit more clunkier. I know how to use C++. It's a lot easier for me to just write C++ code. That's a really powerful thing. That's like an added extra. Finding a tech artist that knows C++, very, very rare. So that's something that I wanted for me, for my career progression, for my standing out, right? But what you'll find is that folks that want to be tech artists, they won't have all of the things on the left. That's the main thing. And so for me, the tech art program needs to give you a generalist foundation because you might be more drawn to certain things. I know we have someone here who said they are a shader specialist. Good. You're totally okay to be a shader specialist. I have a shader specialist on my team. In fact, I have two. They didn't know Python. that was a problem. I needed them to know Python, so I mentor them to know Python, right? Because we want to be able to put folks on projects that can do everything, ideally, right? You want to meld into it. It's empowering to be able to build pipelines and do things like that. So this is sort of the thought process behind the program. I want to build what's on the left, and my background and my experience is what's on the right. I could put a lot more stuff on the right, but there's no need. It would just become a big mess. So I thought I'll just leave it readable. Um, so, how does one become a tech artist? Is the next question. Well, you've got to know shaders. And I think it's really good to know how to use particle systems and how to build them. I think it's really, really important to do that. So that's the first term of the Tech Art program that we're going to launch now. We're going to do shaders first. And is everybody else hear me fine? Sounds like Darshan is having a problem. Yeah, everything's fine. Cool. Sorry, Darshan. That's probably on your end. So this tech art program that we're launching now is skipping the first term, which would be game art foundationals. Most folks who are joining the program have said that they want to skip the first term, and so we're going to do that. And so it's going to be 5 terms, and we're going to start right off the bat with shaders and visual effects. We're going to build shaders together. I'm going to give you the foundational math that you need because we need to talk about math, and we go from there. So that's term 1. We're going to go into shaders so that you have a good foundation and so you can get a feel for what it is that you're going to need to build. We're going to do things like basic atlasing. We're going to do our own flip books. We're going to build distortion shaders. We're going to build water shaders. We're going to do loads of cool stuff and, build master materials, material instances, do things that potentially use runtime virtual textures. There will be lots of things. We're going to discuss distance fields. Shaders are their own thing. And that's the thing. Every discipline here is a big rabbit hole to specialize in if you'd like to. And there's nothing wrong with that. But you need to know blueprints too, because most of the jobs out there are for Unreal. And so we teach Unreal. I'm an Unreal expert. Also an Unreal authorized instructor. And you need to know blueprints. It's really important that you understand programming and programming concepts, and also that you can build tools in the editor that leverage the blueprint system. Blueprints are a core part, they're fundamental to Unreal. And so we're going to teach you how to actually program with blueprints. We're going to do all kinds of cool stuff. We're going to build little game prototypes. We're going to build some tools. It's going to be a lot of fun. I've just finished the I'm basically about to finish because I gave them an extra week to finish their projects, a 6-week boot camp for blueprints that some folks had never used Unreal before. And I'm so super proud of what they've achieved. I'll show you some videos of what they've done. And the content that they are getting in that boot camp, because they have live lessons with me, is the same sort of content that you're going to get because you're just going to have a lot more time because they have 6 weeks. You're going to have 12 of blueprints. So that's going to be a lot of fun. I'm really looking forward to that module as well. We need to talk about proceduralism and tools. You need to know how to build tools and leverage that stuff. So if you know how to do shaders, you can mess with materials, you can do particles, you can do all this stuff. Now you know how to use blueprints. Let's combine them together and let's start building worlds, right? Let's talk about landscape. Let's talk about splines. How do we populate things in the world? Let's talk about PCG. We're going to start building worlds and understand how we can facilitate that construction. How do you build a river system? How do you scatter things along a specific area? All this sort of stuff, like how do you build power lines and roads, all kinds of stuff. So that's going to be term 3. It's all about using our skills in Unreal and getting more generalistic with it. We can build a system to kind of control the time of day and weather, all kinds of stuff. And that can all link to particle systems, right? Depending on what you're doing, you can increase the spawn rate of the rain or fog, all kinds of things, right? And I know there was a question. I will get to questions at the end. So please just hold on to your questions and paste them back if I don't get to them, if I do miss them, right? So that's term 3, procedural content and tools. And then absolutely non-negotiable, Python, your first proper programming language if you've never used Python before. We are going to build tools. We're going to automate processes both in and out of Unreal. It's a really important skill to have. I can't tell you how much it saved me time. My partner's an environment artist. She loves photogrammetry. But if you've ever done any kind of photogrammetry, you understand that you have to, take a picture, move, take a picture, move, take a picture. You go all around an object and you go up, above and down, etc. And you can use something like reality capture to then align all your images. It will automatically do that for you. And then you have to generate the mesh. Then after you generate the mesh, you have to calculate the points, all this other stuff. And you have to babysit the process the whole time. I built a tool that automates that entire process of categorizing all of the images, opening Reality Assist with a command prompt, and taking all the images, processing them, doing all of the generation of the mesh, generating the textures, saving the file to a specific place, and then going for the next one. And something that would have taken us days, potentially weeks to process, I did overnight in like 9 hours because I just left my computer running the Python script. It's incredibly powerful to know Python and understand automation. I can't stress that enough. You would save months and thousands or millions potentially. Most studios, the burn rate every month is millions. You would be saving so much money by being able to automate tasks. And so it's really, really important that we do Python. So that's what we're going to do in term four. So then I thought, okay, this covers most of the things that we want a tech artist to be. At least for me, what I'd like to see in a junior is someone who has all of those. But how do we bring it all together? How do we leverage all of these skills that you have into an extra, a little bit more? We do the final term with advanced procedure workflows, and all of that is focused by linking Houdini to Unreal. And that's going to be the tech art program. I'm incredibly excited for it because no one is going to have a program. Nobody does have a program like this. I'm just going to say it because they don't. And the really, really cool part is that you can go into VFX, or you can go into graphics, or you can go into more advanced things like HLSL, GLSL. You can then go into tooling, gameplay, and automation, both in and out of the engine. You can do so much with blueprints. It's really, really awesome. You could build pipelines, you can automate things, and you can build worlds. That's the, like, you could be a procedural specialist. That's totally normal, and that's totally a thing that a tech artist is. It's a little bit more niche, but having that feather in your cap is amazing. Knowing Python means you could go anywhere. You could do any work that requires automation. It doesn't even have to be in games. You could learn C++. You have a programming language. You understand the concepts. You can go one level further. And these are all things that I have done in my career. I've taken every single little concept and I've gone a little bit deeper, some more than others. I'd say I'm way more on the programmer pipeline side and proceduralism with shaders coming in a little bit after, for example, because that's just served me better to optimize things and build tools and do things like that. But if you need me to build an ocean system, I can build it. I can build particle systems. I can do all these things. It's good to know because then you I had this very senior like engineer talk to me once. And I asked him, I was like, "How'd you keep all this in your head? Like you were writing Python, then you were writing Vex in Houdini, then you were doing C++." And he was like, "Well, you just take one box out, go into the vault and you put the other box in, and then you start using that knowledge. It's really, really powerful." And so I wanted folks to know Houdini because I do think it's really important to be able to generate your own meshes, do things like simulations for both fluids or explosions or volumetrics, generate your own flipbooks. There's loads of things you can do with Houdini where even it will help you in PCG inside Unreal if you want to use PCG instead. Everything's connected, right? Like Epic has a vested interest in side effects. They have, I think, bought part of side effects. So Houdini and Unreal, they're linked together. That's a really important thing. So, you know, what kind of tech artist are you going to be? You can be this kind of a tech artist, focused a lot on shaders, but then you have everything else. That's really cool. You could be the other way around, because I know someone's already joined the program, and in their application letter to us, when I approved it, they wanted to build tools and pipelines. They wanted to automate processes. They want to focus on that. And that's totally okay. It's like going to university, right? Like if anyone's here been through university, you kind of get a feel for everything, and suddenly one of those things clicks with you, and you go, "Wow, I really want to do that. That's what I want to do." So that's an option. This is another option. One of our tech artists here at Vertex, he is called Harvey. He works at Meta, and he is a shader slash Houdini specialist and procedural. He does a lot of proceduralism stuff. But I've had chats about him with Python and things about regular expressions, all sorts of things, because he's a senior and he knows what he's doing. He's got this background. But you can also be a generalist. You can just be a problem solver. You can just be a cog that changes how many teeth you have, and you can slot into any pulley of the machine. So that's the sort of spiel about the presentation and what the tech art program is and why I wanted to build it. I care really deeply about it. Like I'm extremely passionate about teaching, and I want to make sure that for those that do want to join the program, that I'm going to cover what you want to learn. Because in my opinion, tech artists need to know a little bit of everything. It's what I like to call a generalist specialist. And I had this, someone told this to me a long time ago, and I always loved the example. And it was saying that, you should be like a tree. You should have a trunk, and that's your core, that's your strength, that's your base. But from that trunk will sprout many, many branches. And how thick those branches are is really up to you. And branches can then sprout little tiny branches and so on and so forth. Like I've done network optimization, it's not what I specialize in. It's a tiny little branch in one of my branches for C++, for example. There's all kinds of things that if you're just curious enough and you have the skills, you know how to program, then everything's kind of the same. I'll give you a really silly example. I fixed my mother-in-law's Wi-Fi yesterday where one of the installers didn't even know how to do it because I just read the instructions, figured out how the programming of it would work. I went into the router, logged into it, did a change, and everything worked because I had the intuition of a problem solver. And I knew if I just linked a few things together, Googled a little bit, did a little bit of research, I could fix it, right? Like it sounds ridiculous, but it's true. Something I had to do today, for example, at work is I had to figure out how many of our particle systems have CPU simulations in them. Because if you know Niagara, if you've ever used it before, you can do CPU simulations or GPU simulations. And we wanted to see how many CPU emitters we could shift onto the GPU to lighten the load of the game thread, for example. And I built a little tool in C++. It was a function. It was like, I don't know, it was like 6 to 10 lines. And I figured it out and I got a list of, hundreds of particle systems for us to check. You can do many things when you're a tech artist. It just depends what you want to be, right? So I wanted to give a little bit of space for questions. So if you wanted to write out your questions, that would be great, and I can cover them a little bit. And what I wanted to do is, if I move this presentation away, is I wanted to give you a little bit of a demo of something that I teach my students both here and in other tech art programs and blueprints in general on how to build tools on how to do something like this, which is like a little stacking tool. This is one of those things that I like to do, and I want to sort of build this with you together. And I want to show you how I teach people, and I want to show you what kind of experience you're going to have with me when, we want to do some stuff together. So we're going to do something like this today just so you get a bit of an idea. I'm not going to be able to go into all the massive detail because otherwise that'll take a long time, but I will give you a little bit of an example of how to do something like this. Again, proceduralism tool, really cool, right? But you probably want to say, well, it'd be cool to add a little bit of randomness to the rotation here, all this other stuff. It's like, yeah, I agree. We should totally do it. And we will. So that should be a lot of fun. So we've got a lot of you here. I want to ask who has questions. And these can be questions just about tech art or the job industry, anything you want. It doesn't have to be about the program. I'm happy to answer. What kind of computer specs do tech artists typically have? You're a developer. You need high tech specs. It's what you can get, the most that you can get. Lots of RAM, a good GPU, and a decent processor, ideally with plenty of cores. You're definitely, if you're a game developer in any shape or form, you need something pretty substantial. And so, yeah. AI is not going to take my job, Fabrizio. I'm not worried about it at all. The advancement of AI is honestly a bunch of nonsense. AI is there for lazy folks that don't actually know how things work. If you try to vibe code, I saw this word recently and it was just like, oh my God, it's so silly. People are coding, they have no idea what they're doing. They're just chucking code and prompting and hoping it works. It's the blind leading the blind. You can use AI, but if you've never programmed before, stay away from it. You need to learn how to program. And then once you do know how to program, you can ask it for opinions, design patterns, software architecture questions, math stuff that you want to learn. It's a great mentor for many, many things, but it can't write code. And it certainly can't do anything in Unreal. So it's definitely not taking my job. It's very useful. I think it's very useful in the hands of very senior and experienced people. I think it's really dangerous in the hands of juniors because it kind of softens your brain and makes you lazy about thinking. You let it do the thinking. You're outsourcing your thinking. And, you know, that's how I know that I'm going to keep my job because, no one who's doing that is going to be able to compete with, me or someone who completes my course, for example. Um, There isn't a tuition cost for the tech art program at Vertex. Do you know what the cost is? The cost is per term 2,500, and I can give you some links on the website. So you can do it term by term, or obviously do them all in one go. Um, So let me just see. Can you be a tech artist specialized in props? I don't know if you would be specialized in props, but you could be. It depends on what you mean by that. A tech artist is more specialized in a field like tools, automation, right? So you could be a tech artist that's specializing in environments, like sort of technical environment artist. So you do a lot of materials, things with substance painter or substance designer, sorry, those sorts of things. Um, so Orla said, I started learning Houdini because I'm very interested in simulations. What should I focus most on? Well, it depends. I think you need to think where your simulations are going to be used. You need to consider how expensive the simulations are, and you need to bring them into the engine in a way that looks good and is performant. And if you can't do that, then the simulations aren't going to be as useful. So I would look at performance and making them as efficient as possible, depending on what you want to do. Um, So, elaborating on Python and Blueprint fundamentals and how it relates to the industry. So, Blueprint fundamentals are going to be focused on understanding the core concepts of Unreal, building gameplay. And the reason it is going to be building gameplay and tools like the stack tool is so that you get a sort of comprehensive view of how the engine works so that you can then modify it a lot easier. So having something like exposing variables, building things like this here that I'm showing you is really, really important. So on the blueprint side, when you do basic things like understanding actor interaction, blueprint intercommunication, how to build widgets, you then suddenly are able to start building tools, controlling objects in the scene, using the construction script, modifying data real time, things like that. On the Python side, it's all about automation. If I wanted to rename both of these things to, have specific prefixes and things like that, I could select all these three, run a tool, and the tool would then go for each of these assets, check what type it is. If it's a static mesh, put an SM underscore in front of it. If it's a material, put an M underscore in front of it. If it's a texture, put a T underscore. I don't want to have to do that by hand. And, if you have to do it for hundreds of assets, you're going to waste a whole day doing it. That's not optimal. So Python is all going to be all about taking things that are really annoying and making them really easy. We're going to automate the boring stuff, and I'm going to give you really important, fundamental software information. So things like how environment variables work in a computer, like how do computers work, that sort of thing. Did my audio change? Can you still hear me? Okay, cool. Sorry. Yeah. Um, I just had Discord tell me my audio input switched, so I was like, "What are you doing, Discord?" Um, so those are things that I'm definitely going to cover. so that you understand programming on a lower level than most anybody would when they're learning Python. I want to teach you Python like as if you're an artist, not as if you're a programmer. I teach things very differently. And, I have some very happy students, if I do say so myself, because of it, because my stuff isn't really dry. It's very, you know, active and fun and, lots of visual examples, etc. Um, do you know what the course load is going to look like in terms of hours per week? Well, we're going to have one live session that is 2 hours per week. I'm going to be honest, when I was a tech artist, when I was trying to become one, I spent many hours of my day studying after work. I used to commute into London, get on the tube, come back home, make some dinner, and I would work from, 8 to, midnight every day. And I did that for 6, 7 months nonstop because I wanted this really, really badly. So it depends on how much you can give, but I would say you need to have a commitment of a good few hours per week in order to make progress because a tech artist always has to keep learning. You always have the videos and you can do it at your own pace. But at the end of this, which is going to be a long time, you're going to be sick and tired of speaking to me after a year plus. It's a full-on course. It takes, if you see something that says, "Oh, I'll make you a tech artist in 2 months," like that's not possible. It's not possible in three, you know. It's why we have 12-week boot camps here at a minimum that are advanced for folks that want to come in and get a little bit of a dabble. But the program itself to like get folks into it and get them like ready for the industry, it takes a while. You're not going to become a tech artist, like that. With all the skills that you need to learn, there's a lot we need to cover, and we need to go slowly and steady so that everybody gets the concepts. And everybody's at different levels, right? So it's quite difficult. So you have to match it to everybody's needs and skill set. Um, I'm not going to talk about the lighting bootcamp, Darshan. Sorry, it's not my bag at the moment. That's for another instructor. So apologies, I can't give you too much information about the lighting one, but you can send us an email if you have any questions. I'd be happy to answer that. Um, would you recommend the program to someone already working in the industry but self-taught and looking to strengthen fundamentals? I mean, yeah, it depends what your background is and what you want to learn. If you're already in the industry, you're probably, and you're seeking a course, I'd ask you the question, if you're in the industry, you're here for a reason, and you're saying, strengthening fundamentals, is that what you're looking for? 100% this course is about fundamentals. It's going to have advanced things, but you can't be advanced unless you know the core. There's a really interesting like phenomenon that happens where everybody goes and learns Houdini and they learn from these, YouTube channels or even Unreal where they do blueprints. And I see this a lot with my students. All they know how to do is follow tutorials on YouTube. And if they can't find a tutorial on YouTube, they have no idea how to build it. That's not the kind of person I'm trying to build in this program. You need to know how to fish, and I'm going to teach you how to do that. You can't rely on me forever. You can't rely on YouTube tutorials for everything. There's a lot out there, but you need to be able to leverage that information. And when the information isn't there, you need to know kind of where to start going with something to build your own systems. So you have to know the fundamentals in order to, walk before you run, that kind of thing. Any idea what times of the day live sessions are going to be scheduled? Around this time, 6 p.m. my time, because I work full time and I finish at around 5:30. So I'll literally be coming off my full-time job and teaching you right after. So yeah, be ready for me to be like 5, 10 minutes late sometimes because sometimes I overrun with the work that I do. Is there anything that we can do before the course that will help? There is a free course on Vertex that is the coding for creatives, which is by me as well, where we build some tools and blueprints and we get a little bit more familiarity. We talk about blueprints as a way of getting more technical, and then we talk a little bit about Python as well. So yeah. So Lewis has a question. I have previous knowledge in Python from a couple of years ago, but I only used it idly and never used it in UE to create tools or systems. Yeah. My question is how difficult is the switch to go from Python shell like idle to start using it in Unreal and creating tools? So if you've never built UI before with PySide or, some people say Qt, I like to say Qt. So if you've never done Qt windows or anything like that, like we need to learn that. I need to teach you that. The transition is that Python is Python. right? The way you declare variables, lists, data types, all that stuff is normal. How you write a for loop is how you write a for loop. Using the Python documentation for Unreal and the API is a little bit clunky, so you need a little bit more object-oriented like thought process to kind of know what's going on and know what to look for. So the transition isn't going to be super difficult, I expect, but we're not just going to be in Unreal. We're going to go in Maya as well. And the idea is if you're a Blender person, I can help you in the Blender side as well because Python's Python. You know, when I first used Houdini, I didn't use it as a Houdini artist. I went in, I'd never used it before, and I built a pipeline for it. You know, building a custom shelf, buttons, exporters, all that stuff. I didn't even know how to use Houdini. I just looked at the documentation because Python is Python, and I looked at some examples and I started building this stuff. So yeah, you'll be able to transition without any issues. Will there be pre-recorded content? 100%. Every week has pre-recorded content. So yeah. The idea is that you come to the live lesson with me that week, and there's a bunch of video content. It's usually up to 2 hours of video that you need to watch with an assignment, usually every week. So it's a lot, but you know, I'm trying to help folks actually get their foot in the door. And you can see there's a lot of jobs. There's a reason for that. It's because nobody's got the portfolio usually to do that. So seems like those are the main questions that we had so far. I wanted to very, very quickly give you a bit of a demo, right? How did I build this? It's a cool little thing, and I think it's really, really awesome. And you know, I don't want to just run through the code and show you and all this other stuff. Like, I want to build it together, and I want to explain to you the thought process of a tech artist, right? So the first thing to know is that I want a tool that is going to put something in the world. So the fundamental concept here is if it's in the world, it's called an actor. Things in the content browser are called assets. Anything in here is an actor. See, static mesh, actor. And actors are basically
Right.
an object that
Where
has
can I find
transforms.
the air tags? Oh, of
Sorry, gonna.
four four packs.
Tomer, you are unmuting yourself on the call.
Thanks.
Sorry, I'm gonna have to make sure that that doesn't happen. Okay, cool. So again, let's reiterate. Actors are in the world, and all they are is a transform, right? It's just positions, X, Y, Z. That's it. 3D coordinates. It's it's a transformation matrix, basically. It's a transform matrix. So a static mesh actor is just an object with a transform that has these properties assigned to it. So if you wanted to, you could remove the mesh, and it's still here. So all a static mesh actor is an actor that has a static mesh component inside it. And the really powerful thing about actors in Unreal is that they can have components. And components can be many, many things. They can be lights, they can be meshes, they can be skeletal meshes. There's loads of things, right? So I need a tool that goes into the world. So immediately that tells me that I'm going to build a blueprint that is an actor. Cool. So I'm going to call it BP stack tool 2. And I need to think about how my user is going to want to use this tool. Because if you look at this tool here, by default, it doesn't really show anything, but I have a few options. I can get the stack mesh and I can set a stack amount. Okay, I want those things for my artist. I want them to be able to load any mesh that they want. I want that to immediately show up, and I want them to control those parameters. So then I know that what I need to do here, if I move this guy in front here for us, and for those that never use blueprints, you know, don't worry. I'm not trying to make this as something that's, where did I move that window? There it is. Sorry. So for those who never use blueprints, like don't worry about it. You know, we'll cover this in the course if you take the course with us. If you don't, that's okay. So this is the blueprint view. Here's the component section where you can set things. And by default, a blueprint has this default scene root, which is just a transform. It's just a position in the world. We don't need this, so I'm going to remove it. This is a very common newbie mistake. People leave the default scene route. It's wasteful. It's another component that you're considering, especially if it moves. You don't need it. And another thing, it shouldn't tick. It shouldn't update every frame. It'll show up in a profiler. We don't need that. So we're going to add a static mesh component. And the reason we're going to add a static mesh component is only because I want to see what I'm doing. This is like a preview object. That's it. Okay. So for me, this is something I need to kind of get rid of when I hit play because otherwise I have like a duplication, right? So if you look with this tool that we have, it's an actor with a static mesh component inside it. So basically, I've built a static mesh component. So if you drag this into the world, you'll see it's a static mesh actor. There's not a lot of difference here if I do this. You know, I still have a static mesh inside it. I have a static mesh component in here as well, right? So it's interesting to consider it that way. So they're very similar, but a blueprint can have logic, and that's the really powerful thing. So I'm going to delete that here for now. And I need to now think about what my parameters are. What are my inputs? My main input is a mesh. So I need a mesh. So I'm going to call this the stack mesh. And it needs to be of a specific type, right? We want it to be a static mesh. So it's a static object. It's a 3D model, right? So we're going to look for static mesh and we're going to click an object reference. I need the user to be able to modify this. I want it to be modular. So for that, I'm going to make it instance editable and expose on spawn. And if you didn't know, you can hover over most things in Unreal and it'll give you an explanation of what it does. So we're going to do this, and that's great. So that means that I can drag it into the world and I can set a mesh on it. But if I do that, nothing happens. Great. So for that, we have to understand a really important concept in Unreal. And also, let me find the widget reflector. Where is it? Widget reflector. Let me make your life easy and do this. That should make it easier. So there are two phases that we want to focus on today. One of them is the construction script, and the other one is the event graph. The construction script happens every frame, every time you move something, right? So every time you move, you'll get a bit of a electrical signal. I'll prove it. I'll print something on the construction script of the stack tool. So if I drag a stack tool into the world, you might see that nothing's happening. And the reason for it not happening is because the viewport stats are not enabled. This is something that Unreal did. You see all the hellos popped up. So look, hello, 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 right? So it's doing that as I move it. Every time I move it, it's doing that. Every time you change a property, you will get the hello as well. So if I do 3631, I get two hellos for object construction. So we know that this triggers every time a property gets changed. So what I'm going to do is in the construction script, I'm going to take my component that has an empty property and I'm going to set it to be something. So I'm going to go a bit quickly because, again, this isn't a full lesson. I just want to do a bit of a demo. So I'm going to set the mesh because that's what I want to do. And it has a little input. It says, well, what do you want to set it to? Well, I have what I want to set it to, my stack mesh. There you go. So we'll do that. We'll compile, we'll save, and we can do a nice nifty thing, which is to save on compile, on success only. And we are going to move this into here and drag our box into it. Voila. Now we could set anything. This could be a table. There you go. It works fine. So I could stack tables if I want to stack tables, but we're going to stack boxes because it's more fun. So that's what we're going to do. So that's step number one. We can see what we're doing. Great. Now I want to know, well, how many times do you want to stack it? I need to know. So we need a number, right? What kind of a number do we need? We need a whole number. And that's what we call an integer. An integer is a whole number. Floats are decimal point numbers. So this is going to be stack amount. Again, this is something I want the user to set, not me. They need to decide if they're stacking tires, that sort of stuff. Like, I don't know how many they want. We're going to expose it on spawn, make it instance editable, and go from there. So now when we look at the stack tool, we have these two parameters that we can modify. Super cool. Great. Now, the next thing that we want to do in the event graph is somehow be able to spawn more static meshes and place them on top of each other. So for that, we need to spawn meshes, right? So if you do spawn actor from class, it'll say, well, what do you want to spawn? Well, I want to spawn a static mesh actor, right? That's what we want to do. Okay. And there's a really important concept here that I want you to understand. And that concept is that the return value, this function is going to run, and a function is like basically a set of operations that are going to happen, and you can reuse this anywhere that you like. But usually functions give you something back. And the way I like to think about them is like a vending machine, right? So if you need something from the vending machine needs an input. The input is like what's the number of the row that you want the thing? It's usually like a letter and like numbers, right? So like 821 or something. And then it also needs money because if you don't give it money, it doesn't give you the thing. So it has inputs, and this is what this is. These are inputs. So think about our vending machine. We're going to give it what it needs, and then it's going to spit out a soda can, right? And what it spits out is a static mesh actor object reference. So it's a static mesh in the world. But very importantly, if you think about a static mesh, you know that by default, a static mesh actor is just a transform with a component inside it. The mesh isn't set. So we're going to need to set that mesh. That's really, really important. So what I'm going to do is I'm going to drag off of this pin because that is the thing I have just spawned. I have picked the soda can from the vending machine. And we're going to go ahead and we're going to say, hey, set the mesh again, because this is a different thing. This is a new thing that we've spawned. So you see, it's gone into that thing that we've just spawned, gotten its component, and same that we did in here with our component called the static mesh, we need to set it with the stack mesh. So we're going to do that like so. Now, obviously, this doesn't spawn anything because there's no power here. There's no power going to this pin. I like to think as blueprints as power. If there's no power, it doesn't run. If there's no connection, nothing's going to do. So, oh, but this is connected. Yeah, but there's no downstream power, so we can't do anything. I need a button for the person to click. So for that, we're going to do a custom event. Again, I'm not going to explain all these things because we don't have a lot of time. And we're going to call stack. And one of the things we can do is we can say call an editor, and this will immediately show up as a little button for us. And that's cool. So if I try and compile this now, it's going to give me an error. And the reason it's going to give me an error, and by the way, if you want to be a tech artist, you don't ignore errors. So for all the artists that ignore the red squiggles on the bottom of the screen on Maya or Blender or whatever you use, if you have a problem, this is going to end if you join the program. You need to look at errors. So we're going to look at the error. I'm going to read it together. The current value of the pin spawn transform, this guy right here, is invalid. Why? It's because it doesn't know where to spawn it. Doesn't know where to spawn it. So what we can do with these pins, because they're composite pins, a transform is XYZ for location, XYZ for rotation, XYZ for scale. So if we split it, we get this. And by default, it gets 0, 0, 0, 0, 0, 0, 1, 1, 1 for scale. So if I compile and save this, what I can do now is I can hit stack and nothing happens. But the reason nothing happens is because we're spawning it at 0, 0, 0, which is the world origin. So if I go look at the world origin, there's a goddamn box over there. Right? So now we know it's like, interesting. It is working, but welcome to our first bug. So what do? Well, we want to spawn it where we are. So we want to get actor location because we're an actor. And actors have things like locations. So we're going to get actor location and we're going to boop, pop it in there, right? And what we can do now is we can say, well, stack. And there it is. So if you wanted a stamp tool, this is how you do it. If you wanted it, there you go, right? So that's pretty cool. So how the hell do we stack this, right? What do we do? So objects in the world have a bounds. They have a box, right? They have a radius around them. That's really important for us to understand. So what we're going to do is we're going to actually get the bounds of this mesh, our stack mesh, and we're going to figure out the size of it. And what I want is I want to know what's the top of it because I want to put something above it. More importantly than that, I want to do it multiple times, right? So in order to do something multiple times, I need to do what we call the loop. So we're going to do a loop together. So the easiest loop for us to do is a for loop, which unhelpfully, um, when you do for loop, it's not the first thing that shows up. It's this one here. So the way this works is it's basically going to go and say for the ever many times that you want to do something, I'm going to do that same again. So if I do this, it's going to spawn it's going to spawn 6 boxes in the same location. So it's going to go, okay, cool. The first time it starts at 0. That's why I'm saying 6. Important indexes for loops and arrays, they start at 0. Arrays are lists, if you know Python. So that's what we're doing here. So it goes 0, 1, 2, 3, 4, 5. So that's how it works, okay? So this will spawn 6 boxes for us, but they'll all be in the same location. But it will do it. So if we do this and we run the tool, you'll see here it just added a bunch of them. I can just move them. Here they are. See? So that's worked, and that's really cool. So that's cool. That's nice. So let's get rid of all of these because we don't need them. So now what we want to do is we want to leverage this because with every loop we have an index. So it starts at 0, then goes 1, 2, 3, 4, 5, and then stops. So here's the really fun part. This is where we do the magic. So we get that stack mesh and we say, hey, give me your bounds. I want to know what you are. And then it gives me this blue pin, which is what we call a structure. So I know, getting a bit crazy, getting a bit advanced, but a structure is just a collection of variables. Like, this integer is a variable. So it's just packed it all into one nice little box for us. So what we can do with structures is we can either split the pin or we can break structures. And this is what this bounds is. It's got a box extent and an origin and a sphere radius. Interesting. So what I want is the box extents. The box extents of a mesh, if you think about our cardboard box, is wherever the pivot point is usually the middle here. So it's going to be the center of the object. So it doesn't matter where the pivot point is. So if you have a pivot point here, a pivot point, it doesn't matter. It's going to look at your whole mesh and it's going to find the center of it. This is really important that we do it this way, because if you did have a pivot that was wonky and you were not using the box extents, you could have like only certain types of meshes that have a very specific pivot would then stack. So by doing it like this, it doesn't matter what object you have. We get the exact center of it and we say, hey, this is the middle. So the box extent z is going to be the height divided by 2, basically. So what we're going to do is by getting the exact center of the box in the height, I want the top of it. So how do we get the top of it? Well, the exact center or half, we can multiply. So if we multiply this by 2, I get the top of the box. Because I know a box extents give you the middle, so I multiply by 2, I get the top. Cool. So what we're going to do is the first time the loop runs, this index is 0. So it's going to go, okay, I'm going to multiply 0 by the height of our object. And if we looked at the height of our object, like we can try and imagine what it is. It can be like 100 units or something like that. By default, this will be a number, right? Because multiplied by 2, if it's got a size, right? But if we multiply it by 0, the first time, it's not going to do anything, right? It's just going to be what it is. So nothing's going to happen. And we're going to spawn it wherever it is. And that's pretty cool for us. So we do this. And now we need to think about putting the next one above. But because the index is 0, then 1, then 2, then 3, because we're taking the box extent and multiplying it, the second time we run through this, it'll put it above because it times 2. So the first box, 0, doesn't do anything, stays exactly where it is. The next box gets stacked on top of it because we're multiplying it by 2 because it's 1 times 2 the height of the box, right? That's exactly what we're doing here. And then we want to set that as the location. So we're going to use all of this to our advantage. We're going to come in here and we're going to get the actor location like so. We're going to split this pin because I don't want the X and the Y to move. The x and the y need to stay where they are. I just care about the z. So I'm going to split this pin of our vector because a vector 3 is just 3 floats. So we're going to put the x and the y right there. So then what do we do with our z? Well, it's really, really simple. We add this multiplication. So let's work through it together, okay? If this is a bit confusing, because this is the code. It's done now. It's going to work. So if you think about it like this, let's say that the box extends, so the exact, center of it is, say, 50 units, okay? The first time we loop, we get 50 units, we multiply by 2, so we get 100. Then the index is 0, right? The first time the loop goes through. So we're multiplying 0 times 100. 0. So we are adding 0 to the current location. That's it. That's all we're doing, right? So nothing's going to happen. It's just going to stay in place. That's it. And then the x and the y, they are where they are. That's no problem. However, the next time this comes through, we're going to get the bounds again, 50 times 2, 100. But now the index is 1. 1 times 100 is 100. So we take our current location in the world, wherever we are in the world, in the z, wherever we are, and we're going to take the height of the object and add it to it. So then our z is going to be wherever we are. And if we look if we look in the world, for example, the z is 0. We're at 0. If I had it up here, it would take 80 and add 100 to it so that the box would be exactly here. No matter where you've put the box, you can stack it on top. So that's the idea, right? So when we look at the blueprint, this is what's happening. So the first time it stacks, well, it takes the whole height of the box and puts it once. And then the next iteration of the loops come through. This is now 2. We know this is 100. Now it's 200, right? Oh, so then we add it on top of it. If folks could stop squiggling on the screen, that would be helpful. So please. Let me clear that now. Where is the annotation? Cool. So now that we have this, it should work. Let's compile. Let's save. And let's stack 5 times. Done. Look, the first one is at 49. So that's the height of the box. The height of the box is 49 units. Then it's double that, 98. Then it's double that, 147. Then it's double that. Then it's double that. And here's the really cool part. You can now modify whatever you want because you can take this, say, multiplication here or whatever, and you can decide for a random number, but for x and y every time. So you could say random float in range, for example. And I'd like to say set that into the rotation of our mesh, right? So I'm going to take one of these, and I guess I need to find out like where do I want to rotate it? The Z. So I want to rotate it in the Z, not anywhere else. Like I don't want to flip the box. I don't want to tilt the box, right? I just want to rotate it in Z. So that's good to know. Oh dear, oh dear. What have I done here? Okay, so what I want to do is I just want a random rotation now. So I'm going to split the rotation pin, and I'm going to say that I want between, let's say -5 and 5. And we're going to put that into Z. And every time we spawn one, it's going to be either -5 or 5. So then if I take my stack tool, which I totally lost in one of those boxes, so we're going to find it. Sorry, there it is. We're going to now stack it. And look, suddenly skewy. That's the kind of stuff I'm going to teach you in the program. Thank you very much for your time, everybody. I'm happy to answer questions now. But hopefully that was useful and interesting for you. And if you wanted to see some of the stuff that I was talking about as far as making Unreal tools, you can have a look here. I have this tool that published an asset. So you press a button in Maya, it immediately imports everything into Unreal, takes you right to the folder. All the materials are set up. It's made a texture folder, all this other stuff. So all this was done with Python. That's what I wanted to show you. So, what is the breadth of tools learned? No modeling because we're skipping the first term this time. No animation. We're definitely going to look at lighting. We're going to look at effects, so particles. We're going to look at some UI. There's no backend for us to mess with in Unreal in this case. We're going to use blueprints. We're going to learn Python, lots of automation, and we're going to learn Houdini. So lots of proceduralism as well. I'm going to show you how to be an Unreal generalist expert on something that you would like to focus on, because I want folks to specialize in what they like. Uh, when do you build tools with graphs versus building it with code? Depends on the complexity. There are some things you can't do in blueprints. There are some things you don't have access to in blueprints, which is why you need Python or C++. So it really depends what I'm trying to do. So if I'm trying to check if a particle system has a CPU emitter inside it, you can't do it in blueprints. You have to do it in Python or you have to do it in C++. That's what I had to do today, for example. So it depends on what you need. Um, so yeah, everybody. Um, any more questions before I head off for today? And hopefully you've enjoyed it. Hopefully that was interesting for you. And if you want to be a tech artist, we're starting the program very soon. Starts in August. If you want to do everything in the engine as a tooling person, you need to know Python at the very least. You don't need to know C++, but it helps. But we don't teach C++ in the course because it's way too advanced. You need to walk before you crawl. So Python is more than enough for everything you want to do. Um, we teach C++ in the game dev program. The first 4 to 5 weeks of the game dev program is all C++. We build games in it. So yeah, it's that. And the kind of stuff you're going to learn in blueprints is I can show you. Hopefully, I can show you this, and that will work very nicely. We've got some really, really, really cool stuff that the students built that I can show you as a few examples. So really cool. We Matthew is someone who's never used Unreal before, and he did our Blueprint Bootcamp with us. So you're going to learn all this stuff. So he's built things like wall running already. He's literally never used Unreal. So this was his progress after I think week 4. It was a 6-week boot camp. So he already had all of this set up, which was really, really awesome. So directional ramps, all this other stuff. Um, so really, really cool. I taught him how to do like a door and key system, like kind of like the original Doom. He does this really cool thing with the ladders. Like in general, it's just a really, really cool thing. And we had one of our students is a guy called Angel, and he he built this whole like gun customization system, which was absolutely incredible. So this is the sort of stuff that you'll know how to do after you take the blueprint side of us. Um, so are you not able to see the video? Hopefully you can see the video, right? Yeah, yeah, cool. You can see the video. So yeah, this is some of the stuff that, the students are doing, which I think looks really, really nice. They're already building levels, they're already doing really cool stuff. So yeah, learning blueprints will let you do things like this, animating doors, turning on lights, off light, those sorts of things. And this is all going to be really useful because if you want to build any kind of tools for the editor, you should know how the editor works. You should know how games work, how do you build games in Unreal, because then you'll be that much more competent at doing your job as a tech artist because you can speak to engineers and you know why certain things need to be a certain way to integrate with gameplay code. So there's plenty here to discuss. But yes, this is some of the student showcases. So Faran had some really cool like weapon switching happening because I did a weapon switching demo for them. And yeah, it was quite cool. So yeah, this is the sort of stuff you're going to learn on the blueprint side of things. And on the Python side, it'll be tools like I showed you that are on my portfolio, Houdini as well. There's going to be plenty of cool stuff there with simulations and lots of cool stuff with shaders as well. So shaders is the first term, and that's what we're going to start with. But yeah. For environment art, is programming important? If you want to be a tech artist, yes. Um, if you want to just do shaders, maths, more maths than anything than programming. But the course is trying to make sure that everybody has a foundation to there. So that's the idea. I think tech artists need to know how to program. That's kind of what defines a tech artist in my view. You need to know how to automate stuff. Otherwise, you're just like a particle person or a VFX artist. And even they, like VFX artists, are some of the most technical people you know because they're extremely like they're dealing with a lot of data, positions, transforms, collisions. Like you need to know how this stuff works. So yeah. The terms are separate, Marvin, so folks can take as many terms as they want, or they can take all five. You can take only one if you like, or you can take all five. It's really up to you. They are all separate, so you can buy them as you go. What sort of portfolio examples are looked out for? Ask because I want to showcase the correct type of projects. You need to have all the things that we talked about: shaders, Python, tools, you know, a generalist sort of portfolio of showing relatively useful tools that have solved a problem, right? Shaders that are trying to accomplish a visual style or look, particle systems, all these things working together, right? That's usually what you want to do on a portfolio. But you'll have a specialty. So because you'll have a specialty, it will really skew towards that. And we talk about portfolio building and career coaching all throughout the course because that's really important for me to make sure that folks are actually directing their efforts correctly. So as far as what to focus on, it depends on what your specialty is, what you know how to do, and you need to explain everything that you're doing and why it's different, why it's special, you know? So that's what I would recommend. Just make sure you have a breadth of things to show and that they're all high quality. Cool. Thank you, everybody, for your time. I will hopefully catch you in the program. Thank you so much. Take care. Bye bye.